Welcome to the BlueHat Cyber Tidbits series. Short, smart lessons to strengthen your tech foundation. Ever wondered where your photos, emails, and chats actually live? Let's explore the real-world power behind the cloud and what makes it one of tech's biggest innovations. The cloud isn't an abstract space. It's actually a collection of computers in massive data centers distributed across the planet. So, when you upload something, a file, a message, a photo, it travels through real cables to real buildings, where it's stored on hard drives that run 24/7. Companies like Google, Facebook, and Amazon each operate dozens of data centers. Google alone runs over 30, Facebook has many around the world, and Amazon Web Services, or AWS, powers around 30% of the internet. That vacation photo you posted might be stored on a disk in Oregon, backed up in Iowa, and duplicated in North Carolina, all to ensure reliability and speed. The cloud may sound weightless, but it's actually made up of some of the most advanced hardware on Earth. Let's take one simple example, posting a photo on Instagram. When you share that sunset picture, here's what happens, all within just a few milliseconds. First, the image travels through network cables to Meta's nearest data center. Then, it's instantly turned into multiple versions, the original, a compressed version, and a thumbnail, and scanned for faces or locations. Those versions are stored securely on hard drives in Meta facilities in places like Oregon, Iowa, Sweden, and Singapore. Next, copies are made in 3 or more data centers, so even if one fails, your photo remains safe. When someone views it, it's delivered from the closest content delivery network server for faster loading. That one photo now exists in multiple regions, replicated across continents, ensuring both availability and performance. Gmail gives you free email storage, but behind that promise lies one of the world's most sophisticated data systems. Google runs over 30 massive data centers across Oregon, Iowa, Finland, Singapore, Taiwan, and Chile. Each facility houses thousands of servers that process and store data continuously. Here's what happens when you send an email. It travels to the nearest Google data center, gets scanned for ads, encrypted for safety, stored across 3 or more facilities, and indexed for future searches. Even deleted emails pass through stages of temporary storage and backup before they're fully erased, a process that can take weeks or months. These centers consume enough electricity to power over 200,000 homes, showing just how much energy is required to keep our global communication systems online. Your Facebook or Messenger chats also live inside Meta's global data centers in Iowa, North Carolina, Oregon, Sweden, and Singapore. Messages are replicated across multiple centers for reliability. They can be analyzed to improve features like spam detection, ad targeting, and AI moderation. Deleted messages often remain in secure backups for a limited time to protect against data loss or accidental deletion. It's all part of ensuring that the system remains stable, responsive, and resilient, even as billions of users send messages every day. So, artificial intelligence works through the same cloud infrastructure, just in a more advanced way. When you chat with an AI model, your message travels to specialized GPU servers hosted by cloud providers such as AWS or Google Cloud. Those servers run complex neural networks with billions of parameters that generate responses in real time. Here's what happens. Your message is sent to an inference server, processed by the neural network, a response is created, and then sent back to you. Conversations are stored temporarily, typically for 30 to 90 days, for safety and monitoring purposes. These servers rely on high-performance GPUs, which were originally designed for gaming, but are now repurposed for AI computation. Each reply you see is powered by real hardware, real compute, and real electricity, often processed in locations like Virginia or other cloud regions around the world. A data center is like a digital fortress. a blend of precision engineering and constant motion. Inside, you'll find server racks stretching for hundreds of feet, stacked from floor to ceiling. Cooling systems the size of trucks move air and water to control temperature. Power infrastructure comes with backup generators, redundant supply lines, and entire walls of batteries, because even 1 second of downtime can mean millions in losses. Security measures include biometric scanners, man traps, 24/7 guards, and camera surveillance. Fiber optic cables carry data at terabits per second, connecting these centers across continents. Getting access to one is harder than entering a bank vault. And honestly, that's for good reason. The scale of cloud computing is astonishing. Facebook stores over 100 petabytes of data. That's more than 1 million gigabytes per petabyte. Google handles 3.5 billion searches every day, and all of them are logged and processed. AWS powers about 30% of the entire internet. Together, global data centers consume 1 to 2% of all the world's electricity, the same as some entire countries. Cooling these facilities requires massive amounts of water to prevent overheating. Just one email emits about 4 grams of CO2. Streaming a Netflix show for 1 hour uses about 3.2 kilowatt hours of electricity, and storing your cloud photos draws power 24/7. The cloud is honestly one of the most energy-intensive and essential systems ever built. So where is cloud technology heading next? Innovation is happening fast. Underwater data centers are being tested for natural, ocean-based cooling. AI-optimized chips are making computation faster and more energy efficient. DNA storage could one day store 215 petabytes in a single gram of material. Edge computing brings processing closer to users for faster, more private experiences. Quantum storage could expand capacity exponentially by using quantum states. And green energy projects, powered by wind and solar, are becoming the backbone of new data facilities. The trend is clear. Computing is becoming closer, cleaner, and more efficient. But no matter how advanced it gets, data will always require real machines and real power. Every photo, email, message, or AI chat you create adds to humanity's greatest shared archive, the digital record of our time. So, the next time you upload a file, send a message, or stream your favorite show, remember, the cloud is very real. It's a global network of machines, cables, and energy working together to keep the world connected. And that's what makes it one of the most fascinating and vital technologies on Earth. If you'd like to learn more about the amazing systems behind everyday technology, like, share, and subscribe to BlueHat Cybersec Academy for more insights into how the digital world really works.